Before we begin, let us have a refresh on cluster sampling issues. When I say multi-level modeling, we say multi-stage sampling. The advantage of multi-level modeling is, as I told you at the beginning, it allows you to bring the risk factors at various levels and model it, which it's not possible in any other technique. Regression technique means you just deal with only one level variables. If you want to go to the higher level, say for example, we said doctors' qualification or experience, so covariate. Patient characteristics as covariates. So only the multi-level modeling, you can use that kind of analysis. So there are 12 doctors, their experiences can be modeled along with the patient level variables. Otherwise, you cannot do it in any other regression. Plus, if you bring in institution level, say for example, 500-bedded hospital or teaching facility and so on, these are all covariates about the facilities that can be modeled along with the patient characteristics. There is a big advantage of doing this kind of analysis with the multi-level model. So cluster sampling, which tells you the different level, I'll just touch on that one. There are some issues which we need to, somebody has said, how to calculate sample size in multi-level modeling and multi-stage sampling and so on. So cluster sampling is basically that it reduces your cost, time, etc. But the penalty that we need to pay is that larger variance in the cluster sampling studies. The day one morning, I said the cluster sampling done at the cross-sectional level, cross-sectional studies, cluster sampling, when you adjust for the clustering effect, it increases your standard error. Please remember, that's a cross-sectional approach. One time you measure patient outcome as well as the exposure. If you adjust for the clustering effect, then it increases your standard error, reduces the false positive results. Please remember, that is a cluster sampling in a cross-sectional studies. So these are all some of the multi-stage sampling advantages that you can read and find out. And as I said, the cost can be reduced and so on. This is what important. Different frames are used at different stages and also more than one frame at any stage. So different frames are used to say, for example, when I say my class students are sampled in a classroom and schools are sampled. The schools are limited. It's not like students, hundreds and so on and so forth. The samples of schools are limited, therefore you will use a different sampling scheme as compared to selecting the students. So at different level, different sampling use can be used in a cluster sampling design. What I wanted to tell you is this. This is very easy to read these slides. The unit of analysis is not individual, it is a cluster. That is what we need to remember. That is what we are doing now here. And this is, we have done a big study on antibiotic prescription pattern studies. We wanted to know what is the prevalence of antibiotics prescription for unwarranted conditions. That was around 50–60% reported everywhere. So the doctor is a cluster because he gives lots of prescriptions. So prescription, the unit of analysis is a doctor, the cluster sampling issues. Those days we have not used multi-level modeling or whatever. So a very important slide. This is, say for example, the variance between clusters and variance within cluster. So we have been talking about doctors, and this is between doctors variability and within doctor variability. Within doctor means his patients are clustered within the doctor. So patients variability within a doctor. And this is between doctors. So this is intra-class correlation coefficient between variance, between cluster variances and the total variance. This is what we are going to do today. Today, I said it is a subject-specific model. It is individual-specific model. Therefore, you would be able to exactly estimate how much of correlation going on in my study. That is intra-class correlation coefficient. That is adjusted in the analysis. Yesterday's population average model, we assume that mostly it is an exchangeable correlation structure. It gets adjusted in the regression analysis. So you don't have to do that today because it estimates exactly the amount of correlation. Okay. Today, we are going to address the issue, should I do adjustment at all? That is something which we need to understand. Sometimes we'll say that there may be a correlation and so on and so forth. There may not be any correlation. So you have to decide whether this data needs that kind of analysis. Sometimes another viewpoint is that anyway, we know the technique, there is a cluster structure. Therefore, let me adjust it, whether it is useful or not. Okay. Also said in the repeated measures concept that there's an advantage you would be able to get higher level of significant level, a number of variables. So this is a dependence in the response individual within the cluster. That is, let me explain this. If you say, if somebody asked you what is intra-class correlation coefficient, the correlation of responses of the subject within the cluster. You say, for example, I study the prevalence of malnutrition in a community. My cluster is a household. I take all the children in the household. So, because they are sharing the same kitchen in the household. Therefore, if one is malnourished, the other one is expected to be malnourished. Therefore, the responses within the cluster are correlated. How much that kind of correlation going on? That is called intra-class correlations. Responses within the cluster, whether they're correlated or not. That is something which you need to know. So therefore, it has to be adjusted. So if the common sense concepts here, the cluster size is very small, the ICC is expected to be very high. As the cluster size increases, when you move from household to village, you are studying many number of children, then the correlation weakens, reduces. Whereas if you take a household as a cluster, the cluster ICC is expected to be larger. The smaller the size within the cluster, we expect a higher correlation. The value of ICC declines with the size of the cluster. Okay. Family, classroom, etc. will be higher than the larger clusters and so on. These are all just the common sense concepts. So this is what we said. We have been discussing about statistical techniques are no longer appropriate. The p-values will be artificially extreme. CA will be over narrow, very narrow. So when you do the correct adjustment, correct analysis, it will be wider. So therefore, the data on ICC and sigma square, the variance statistics between cluster has to be reported. So we have done a very big study from CMC on STD and HIV in Tamil Nadu, the first time in 1998, which reported HIV prevalence in India. We never reported what is a cluster-based design. Okay. So we never reported the ICC in our paper. People don't present the ICC in our papers when they write to serve as as a data for calculating sample size for the next generation or next papers, etc. That is something. This is somebody asked me, how do you exactly calculate put my ICC in my sample size calculation? It's very difficult. So in a cluster sampling, that is why I said the cluster sampling studies, the sample size is inflated by 2 times conservatively, or 2.5 times conservative, because you don't get the value of ICC reported anyway. These are all some of the concepts. Now, there's another important concept. People design studies for cluster sampling. Now, let me give you an example. If I have to have 1,000 children to be studied, selected randomly using cluster sampling approach, I have a number of clusters. ICC is fixed. Say, for example, ICC is fixed. So the question is, should I take 20 cluster, each cluster 50 children? So therefore, you'll have 1,000 children. Option 1, 20 clusters, 50 children in each cluster. or 50 clusters, 20 children in each cluster. Which one do you prefer? Do you understand my question? Okay. Which combination gives you more power? Okay. Let us look at this slide. I said the ICC is fixed, for example. Cluster size is 100. Design effect is fixed. This is inflation factor. This is basically number of clusters. So if I take 5 cluster, inflation factor or design effect is 5, size is 100, and the power is 82. Then someone said, no, let us have, say for example, this is 100, same size, but increase the number of clusters. Okay. Increase the number of clusters to 6. What happens in your power? It increases to 88. So similarly, somebody said, let me take 200 subjects per cluster and 5 clusters. So how much is the increase in your power? Only 5 units. But rather, if you take 100 with 6 clusters, the power increases to 88. Do you understand the difference? So therefore, you have to increase your number of clusters rather than number of children. Higher the sample size increases the power is a wrong concept. Here in cluster sampling, number of clusters, if that get increased, then it increases your power. Okay, that is all I have here. So these are all the things which we have been talking about. So this is a formula which we use to calculate design effect. So design effect, there's a row, the ICC is not known to us many times. People don't report it. Or you have to do a small study and estimate that row and then put it in the formula. And see as what happens if your sample size increases per cluster and in the row in the design effect and so on. So that is not our focus. We'll go back to our multi-level modeling. So please remember, if somebody asked you, why should I do multi-level modeling? Okay. Because the subjects coming from a level, doctors are correlated to each other in their responses within the doctor level. So therefore, it has to be adjusted. That's a correlation effect. Plus, it also allows you to take the doctor's characteristics into the model. I said someone has written from Harvard University or whatever. So whether he is doing very well in terms of the measurement which is derived from the patient's level, as compared to someone from a local doctor who is an MBBS. So this is, you can model these variables into the model and address the questions. Do you have any questions in the cluster sampling? We'll discuss it.